April 6, 1945. The waters south of Okinawa. The horizon burns. The sky above the U.S. Fifth Fleet trembles with black smoke and streaking fire. A Japanese Zero. Its rising sun insignia, barely visible through the haze. Hopping. Dives toward the sea. Its pilot's eyes locked on the silhouette of an American carrier below. His fuel gauge is empty, his fate sealed. On the decks, sailors scream warnings. Aircraft batteries roar to life, their muzzles thundering in desperate unison. For months, these gunners had fired blind, hoping to hit a moving speck in a storm of speed and chaos. But today something is different. Shells burst, not behind, not below, but exactly where the aircraft moves. Invisible sensors detonate midair, judging distance with machine precision. Each explosion finds its mark before the bullet even touches metal. The Zero disintegrates, a flash in the sky, vaporized long before it can reach its target. No one aboard the carrier understands how, only that, for the first time, the kamikaze wave breaks before impact. This was the moment Japan's deadliest weapon met an American invention it could neither see nor comprehend. The proximity fuse. By late 1944, the Pacific War had entered its most brutal phase. The tide that once carried Imperial Japan across Asia now pulled it backward. Island by island, mile by mile, the American counteroffensive, forged in the blood of Guadalcanal and the coral of Tarawa, had reached the Philippines. Behind every new island seized, the United States constructed airfields, fueling stations, and forward bases, stepping stones leading directly toward Japan's home islands. For Japan, each lost island meant another wall of defense collapsing. Its fleet, once the pride of the Pacific, lay shattered after the Battle of Leyte Gulf in October 1944, the largest naval battle in human history. The Imperial Navy had gambled everything to repel the Americans from the Philippines. They lost 4 carriers, 3 battleships, 10 cruisers, and nearly every trained pilot who had survived earlier campaigns. By then, Japan's skies had become a graveyard for its airmen. American Hellcats dominated from above. U.S. radar-directed anti-aircraft fire blanketed the approaches to every fleet. And yet, despite mounting casualties, Japan refused to surrender. Desperation birthed something new, something both horrifying and tragic. It began quietly in October 1944, during the fighting around Leyte. A special attack corps, Tak Tai, was formed under Vice Admiral Takajiro T. Nishi. Its purpose was as simple as it was suicidal: crash aircraft directly into American warships. Each pilot, often barely out of training, was told that their sacrifice would save Japan from invasion. The word kamikaze, divine wind, carried echoes of the legendary storms that had once destroyed Mongol invasion fleets centuries before. Now, the empire sought a modern miracle through human sacrifice. Early kamikaze attacks stunned the Americans. On October 25, 1944, 5 planes from the 201st Air Group struck the escort carrier USS St. Louis. The ship erupted in flame and sank within minutes. The U.S. Navy had never seen anything like it. pilots, deliberately guiding their planes into steel decks, turning themselves into living bombs. Admiral William Bull Halsey, commanding the Third Fleet, called it a new kind of enemy, one that doesn't care about dying. In the months that followed, kamikaze raids multiplied. Between late 1944 and early 1945, more than 1,000 suicide sorties were launched across the Philippines, the South China Sea, and eventually toward Okinawa. Each carried a 250-kilogram bomb, enough to tear through armor and ignite aviation fuel deep inside a carrier's hangar. The psychological effect was devastating. Radar operators tracked dozens of blips, diving straight at them, knowing that even a single miss could mean hundreds of deaths. Gun crews fired until their barrels glowed red. Some ships were hit by as many as 6 or 7 kamikazes in a single day. The United States Navy began to learn, adapt, and harden. Fleets were reorganized into layered defense formations. Destroyers formed protective screens, carriers operated further apart, and every vessel bristled with anti-aircraft guns. Yet even with improved radar and better coordination, the defense remained largely a matter of chance. The mathematics of survival were brutal, hundreds of shells fired for every plane destroyed. For a kamikaze pilot, all it took was one to slip through. And by early 1945, as the Americans prepared to invade Okinawa, just 340 miles from Japan, the Imperial General Headquarters unleashed the largest suicide offensive in history. It would be called Operation 10 Go, and it would throw over 900 aircraft against the U.S. Fifth Fleet. But unknown to Japan's planners, the Americans had already armed themselves with a silent revolution, one that would make all previous anti-aircraft technology obsolete. A weapon so precise it seemed to think for itself long before kamikazes appeared over Okinawa. A secret race had already begun in laboratories and research sites across the United States. Its goal: to solve one of naval warfare's oldest problems. How to hit a fast-moving aircraft in 3 dimensions with a shell that could never be guided once fired. For decades, anti-aircraft gunners had fought against physics itself. Shells traveled miles upward, through unpredictable wind and weather, toward targets moving hundreds of miles per hour. Even the best crews, aided by radar and analog computers, could only guess where a plane would be a few seconds later. Most shells burst harmlessly behind or beneath their targets. In 1940, this was still the grim reality of air defense. But in a cluster of unassuming American labs, the Carnegie Institution, the National Defense Research Committee, and later the Applied Physics Laboratory at Johns Hopkins, a small group of scientists began experimenting with a radical idea: a fuse that could sense its target. At the center of the effort stood physicist Merle Tuve. He and his colleagues envisioned a shell containing a tiny radio transmitter and receiver, a miniature radar. As the shell flew through the air, it would emit radio waves. If those waves bounced back from a nearby object, hopping, The fuse would detect the change in signal strength and detonate instantly, at the perfect distance, to shred its target with shrapnel. It was a simple principle, with impossible demands. The device had to survive the 20,000 g acceleration of being fired from a naval gun. It had to fit inside a few cubic inches. It had to be utterly reliable. Early prototypes shattered under firing stress. Circuits failed. Batteries died in seconds. Yet Tuve's team persisted, shielded by secrecy and urgency. The war had already spread across Europe and Britain, enduring nightly Luftwaffe raids, pleaded for help. By 1942, American scientists had done what most considered unthinkable. They created a working radio fuse small enough, strong enough, and intelligent enough to detonate at just the right distance. It was designated the VT fuse. For variable time, to maintain secrecy, production was disguised under mundane contracts. Over 22 million units would eventually be made, each one hand tested, each a triumph of wartime engineering. The program's cost rivaled that of the Manhattan Project, but unlike the atomic bomb, its existence was hidden even from many senior officers. The U.S. Navy began testing the new shells in late 1942. Results were immediate and astonishing. In the Solomon Islands campaign, ships armed with VT, fused 5-inch guns found their accuracy improved by a factor of 5 to 10. Where once they fired hundreds of rounds per kill, now they needed only dozens. Admiral Arleigh Burke later called the proximity fuse the most important new weapon of the war, next to the atomic bomb. By 1944, as American fleets advanced across the Pacific, the technology spread quietly through the fleet. Destroyers, cruisers, and eventually carriers received the new ammunition. Its use was kept secret, even from Allied nations at first, to prevent the Germans or Japanese from capturing a shell and discovering its mechanism. To the men who fired them, the difference was almost mystical. Targets that had always seemed untouchable, fast, weaving aircraft, now burst apart mid-dive. Gunners described it as watching invisible hands swat planes from the sky. But when Japan unleashed its waves of kamikaze pilots at Okinawa in April 1945, the full power of the VT fuse was revealed. Here, the stakes could not have been higher. Over 1,500 suicide planes were launched in just a few weeks. Each sought to crash into an American warship. The U.S. Navy had prepared its defenses, but no man could prepare for what it meant to face a human weapon. Only technology could meet it head-on. And as the first Zero broke through the clouds toward the fleet, the invisible sensors hidden inside America's shells waited, listening for echoes, ready to detonate with mathematical perfection. For the men of the Tai, the path to death began in quiet airfields scattered across Kyushu and the Philippines. Most were no older than 20. They had grown up in an empire that preached divine destiny and loyalty above life itself. In the final year of the war, that loyalty was weaponized. Training airfields turned into sanctuaries of farewell. Pilots were told their mission would save their families, their emperor, their nation. They wrote final letters, took ceremonial cups of sake, and tied white headbands, hachimaki, around their foreheads, painted with the red sun of Japan. Many wept. Some laughed nervously. Others stared into the ground in silence. They had only a few weeks of flight instruction, barely enough to land or navigate. Many could not even perform aerial combat maneuvers. Their aircraft, the Mitsubishi A6M0, Ki 43 Oscar, and others, were loaded with 250-kilogram bombs and stripped of armor to lighten the load. A kamikaze pilot's mission often lasted less than 2 hours. After takeoff, they flew low over the ocean, avoiding radar. When they reached enemy fleets, they climbed into the sun, turned toward the largest silhouette, and began their dive. Few reached their targets. Most were cut down by flak or intercepted by American fighters long before impact. But those who broke through left searing memories on the men they attacked. American sailors watched the incoming planes with disbelief. Many thought at first they were simply reckless attackers, until they saw no sign of retreat. No evasive roll, no last-minute pull up. Just a straight dive. Even hardened veterans felt their stomachs twist. For the gunners, shooting down a kamikaze was not victory. It was survival. There was no joy, no cheers. Just another plume of black smoke. Another pilot gone. Another ship spared. And for the pilots who died, few truly believed in victory anymore. Some diaries, recovered after the war, reveal doubt and resignation. One young man wrote, "I am not afraid of death. But I wonder if it will change anything." Their courage was unquestionable. Their fate was inevitable. To understand the shock of the proximity fuse, one must imagine the battlefield from a gunner's sight. Before 1944, anti-aircraft defense was a storm of guesswork. Radar operators called out bearings. Rangefinders calculated altitude. Fire control computers predicted where a plane might be seconds later. Gunners then fired hundreds of shells, hoping the pilot would fly into the explosions. Each shell detonated on a timer, sometimes too early, sometimes too late. The sky filled with puffs of black smoke and the metallic echo of wasted effort. Then came the VT fuse. The tiny device inside each shell turned every round into an intelligent weapon. When fired, it emitted radio waves as it flew. If those waves struck a nearby object, the fuselage of a plane, a wing, or even a propeller blade, the returning signal changed. Within milliseconds, the fuse triggered detonation. The explosion occurred not on impact, but at the right distance, roughly 70 to 100 feet from the target, maximizing the shrapnel's reach. This single innovation multiplied effectiveness several-fold. Navy destroyers that once fired 2,000 rounds per kill now averaged fewer than 500. In some cases, one well-placed barrage could destroy multiple aircraft. The system required no new guns, no retraining, only new ammunition. And because its workings were invisible, the Japanese had no idea why their attacks suddenly failed. To them, it seemed as though American gunners had achieved impossible accuracy. The proximity fuse was, in truth, the marriage of science and war at its purest. An invisible, thinking guardian that made every shell a hunter. Yet even this intelligence was tested to its limits, when Japan turned its entire remaining air force into guided missiles of flesh and bone. By early 1945, American naval commanders had refined their fleet defense doctrine into a deadly machine. Every ship, every aircraft, every gun had a place in the network. The standard formation centered on aircraft carriers, the heart of U.S. power projection. Surrounding them were cruisers, then destroyers, and finally picket ships positioned far ahead, as the first line of radar detection. Radar stations on the picket line would track incoming aircraft, often from over 100 miles away. They would alert combat air patrols, groups of Hellcats and Corsairs, circling high above the fleet, to intercept those that broke through. Met the outer flak barrage, directed by radar, guided fire, control systems. The last line was the close in defense. The rapid-firing 40mm Bofors and 20mm Oerlikons, manned by sailors who aimed directly with their eyes, hearts pounding as planes roared toward them. Into this layered shield came the proximity fuse. Its integration multiplied the effectiveness of every gun battery. The outer ring of 5-inch dual-purpose guns, once a relatively blunt tool, now became the fleet's most lethal barrier. The difference was visible from the bridge. Commanders reported kamikaze formations disintegrating before they reached visual range. The sky erupted in concentric rings of explosions. Detonations perfectly spaced along the flight path. Fleet officers began to trust the invisible science. Gunners felt, for the first time, that their hands could keep up with the speed of death. Still, the tension never eased. The proximity fuse did not guarantee safety. It only gave seconds. The difference between a flaming ship and a near miss. For the kamikaze pilots, those same seconds were the wall between glory and failure. For the Americans, they were the boundary between life and annihilation. The battle between belief and technology was set, and the island of Okinawa would become its proving ground. At the highest levels of command, the struggle between Japan and the United States in 1945 was not merely about weapons or ships. It was about belief. In Tokyo, Vice Admiral Takujiro T. Nishi sat at the heart of a crumbling empire. When he proposed the first organized suicide units in October 1944, even some of his own officers hesitated. Japan had always honored sacrifice, but never industrialized it. Yet, T. Nishi saw no other path. If we are to save Japan, he told his subordinates, there is no choice but to die gloriously. The emperor's government approved. The TOC command was born. The Special Attack Forces. Thousands volunteered, many pressured by propaganda, others out of genuine devotion. T. Nishi promised that one plane, one life, could equal one ship. The arithmetic of desperation. Across the Pacific, leadership looked very different. Admiral Chester Nimitz and Admiral Raymond Spruance, commanding the vast U.S. Pacific Fleet, relied on coordination, technology, and logistics. To them, war was not a matter of honor, it was engineering. Every loss was measured, every adaptation analyzed. When reports of kamikaze attacks began to arrive after late Gulf, Nimitz did not respond with emotion, but with analysis. He demanded improvements in radar coordination, ammunition supply, and fighter coverage. The proximity fuse was classified at the highest level, known only to select officers and technicians. Even frontline commanders like Admiral Mark Mitscher, leading carrier task forces, were ordered never to let a single fuse fall into enemy hands. If a ship carrying them was at risk of capture, it was to be destroyed. The weapon's existence was guarded more tightly than any other except the atomic bomb. Leadership, on both sides, reflected the soul of their nations, Japan's faith in sacrifice versus America's faith in science. One fought with bodies, the other with circuits. When their doctrines finally collided over Okinawa, the result was the most violent sea-air battle in human history. To the men aboard U.S. ships, the kamikaze was not an abstract concept. It was a shape in the sky, growing larger every second. The moment radar spotted an incoming wave, a chilling word echoed through the decks. Bogies inbound. Sirens wailed. Men sprinted to battle stations. On destroyers, gunners lined up behind their mounts, scanning the horizon. In the distance, specks shimmered in the sun, then multiplied. 50, 60, sometimes 100 aircraft approached. For sailors, time dissolved into adrenaline and dread. They watched as one plane caught fire and spiraled into the sea, only for another to slip through the flak. Some ships were hit multiple times in a single day. The deck shook with every explosion. Psychologists who later interviewed survivors found recurring descriptions. It felt like a storm that thought. These were not random waves of attackers. Each plane had intent. A human will behind its fall. For the Japanese pilots, the psychology was no less intense. In final letters, many wrote of serenity, but others confessed confusion. They were told their deaths would turn the tide. Yet by 1945, Japan's defeat was already certain. Their teachers, parents, and officers had promised glory. But glory had become a whisper in the smoke of Okinawa. American sailors, despite their technological advantage, felt guilt after battle. They knew each incoming plane carried a man who had already accepted death. The proximity fuse, in its eerie precision, made death impersonal, fast, inevitable, without eye contact or final defiance. It was psychological warfare in reverse. Japan tried to terrify through devotion. America responded with indifference made mechanical. In that collision of emotion and cold calculation, the humanity of both sides blurred. The proximity fuse raised moral questions that went beyond tactics. Its effectiveness turned the sky into a machine of death, one that no human could outthink or outrun. For the scientists who built it, pride was tempered by awareness. Merle Tuve later said, "We built something that made killing effortless." Yet he also knew it saved countless American lives. The same equation haunted military ethics after the war. The kamikaze, in contrast, was the ultimate human weapon, a soldier giving everything, willingly. To many in Japan, it symbolized purity of spirit. To others, it was the empire's most unforgivable manipulation. The proximity, Fuze, embodied the opposite, a triumph of intellect over emotion. It did not feel, it did not fear, it did not mourn. It simply measured, calculated, and destroyed. Both sides, in their extremes, revealed something about modern war. Japan's faith in human sacrifice belonged to an older world, one of swords, flags, and honor. America's new weapon heralded the future, a future of electronics, computation, and distance. When these forces met, history crossed a threshold. War was no longer a contest of courage, but of invention, and at Okinawa, that threshold would explode into reality. As dawn broke over the Pacific in April 1945, the fleets faced each other. Thousands of men preparing for death, thousands of machines waiting to kill. In the coming weeks, the proximity fuse would prove itself, not in laboratories or test ranges, but in the chaos of the largest kamikaze assault ever launched. April 6, 1945, the first day of hell. At dawn, the radar screens aboard the U.S. Fifth Fleet lit up with dozens of blips moving in from the north. Then hundreds. It was the beginning of Kikusui no 1, the first of 10 massed kamikaze attacks that would define the Battle of Okinawa. Admiral Raymond Spruance's fleet stretched across the sea. More than 500 vessels guarding the invasion of Okinawa's beaches. The island itself was already a cauldron of fire, with American Marines and soldiers fighting through caves and ridges. But offshore, a separate war raged, a war for survival against the sky. At 11:30 a.m., radar picket stations, destroyers positioned far ahead of the main fleet, reported incoming formations at altitudes between 3,000 and 10,000 feet. The code word flashed through every ship: bogies inbound. Large formation. The U.S. Navy's combat air patrols. Hellcats from the carriers Bunker Hill, Essex, and Intrepid scrambled to intercept. Dogfights erupted in the blue void. Dozens of Japanese planes were torn apart before they ever reached the fleet. But still, many broke through. On the horizon, gunners saw the glint of sunlight on wings, the white trails of exhaust slicing through the sky. Kamikazes approached in waves of 5, 10, sometimes 20 aircraft, diving low over the sea to avoid radar. Each carried a 250-kilogram bomb, sometimes 2, lashed under the fuselage. Then, the anti-aircraft guns opened fire. From destroyers, cruisers, and carriers, thousands of shells filled the air, creating a dome of explosions over the fleet. The 5-inch dual-purpose guns, armed with the new VT proximity fuses, roared in rapid sequence. To sailors watching from below, it was unlike anything they had ever seen. Shells detonated in perfect rhythm, not behind the planes but around them, bursts of orange and black that shredded wings and engines mid-dive. The proximity fuses were working exactly as designed, detonating within meters of their targets. The first 0 to breakthrough exploded before reaching the destroyer Pickens. A second disintegrated as it approached the cruiser St. Louis, fragments raining harmlessly into the ocean. For the first time, gunners didn't have to guess. The shells found their targets themselves. But there were too many. Despite the deadly accuracy, some kamikazes got through. The destroyer Bush was struck twice in 5 minutes, engulfed in flames, and sunk with heavy loss of life. The Callhound followed hours later. Even with technological miracles, no defense could stop everything. Over the next 48 hours, more than 350 kamikaze aircraft were launched. 32 American ships were sunk or damaged. The fleet endured an attack intensity unseen in naval history. Yet amid the chaos, the proximity fuse changed the balance. Analysts later estimated that half of all kamikazes destroyed before reaching their targets were brought down by VT fused shells. Aboard the carrier Bunker Hill, sailors described the spectacle as a sky full of invisible traps. Every dive bomber seemed to fly into a wall of fire that wasn't there moments before. For the Japanese, it was incomprehensible. Pilots reported explosions in midair, often far from visible gunfire. Many believed the Americans had developed some new form of radar, directed beam, weapon. None understood the truth, that the shells themselves were listening for them. By nightfall, the ocean glowed with burning oil and twisted wreckage. Survivors clung to debris under the fading light of tracer rounds. Above them, the stars returned, silent witnesses to the day's carnage. The first Kikusui wave had failed to destroy the fleet. The Americans were bloodied but unbroken. And though Japan would launch 9 more suicide waves in the coming weeks, the invisible edge of the proximity fuse would only sharpen. Each day, gunners grew more confident. Each barrage became more lethal. The weapon that once hid in secrecy was now rewriting the very physics of naval defense. Yet, amid success, fatigue grew. For sailors who had fired thousands of rounds, the sound of each detonation became a drumbeat in their minds. Even after the raids ended, some swore they could still hear the explosions echoing over calm seas. The battle was far from over. The greatest test and the clearest proof of the proximity fuse's power would come in the days ahead, when Japanese planes swarmed in their largest, coordinated assault of the war, and one ship, a single destroyer named Laffey, would become its crucible. The destroyer USS Laffey stood alone on the gray horizon, one of the forward outposts, guarding the fleet from incoming kamikazes. She was small, fast, and vulnerable. Armed with 6.5-inch dual-purpose guns and surrounded by a web of radar-directed fire. Her crew of 336 men had been fighting for weeks, exhausted but resolute. At 8:30 a.m., the radar operator's voice cracked over the intercom. Multiple bogies, inbound. Range 30 miles, closing fast. Moments later, the horizon filled with dots. Then shapes. Then the scream of engines. 50 Japanese aircraft, Zeros, Oscars, and Vals, were diving toward the single destroyer. The order went out, "General quarters! Man all guns!" The 5-inch batteries thundered. Each shell carried a VT proximity fuse, the ship's most precious secret. As the first formation descended, bursts erupted in precise intervals, encircling the sky around Laffey in lethal blossoms of steel. Planes began to fall immediately, torn apart mid-dive, exploding before they could aim. Observers later said it looked like a wall of invisible hands, batting them from the air. But numbers overwhelmed technology. Within minutes, Laffey was under attack from all directions. One kamikaze struck her aft gun mount, killing several crewmen. Another smashed into the stern. The ship caught fire, her decks slick with burning fuel. Yet the gunners kept firing. Every 5-inch gun, every 40 mm and 20 mm mount, spat fire. The proximity fuses detonated in perfect bursts. Clouds of shrapnel tearing through the next wave before they could reach their target. 22 enemy planes were shot down in less than 15 minutes. The air around Laffey turned into a continuous storm of explosions. Still, they came. A Val dive bomber broke through, slamming into the bridge. Another clipped the mast before crashing into the sea. By the time the attack ended, 6 kamikazes had hit the ship, and 12 bombs had exploded nearby. Yet Laffey refused to sink. Her gunners, some fighting with bloodied hands, stayed at their posts until the last attacker vanished. When smoke finally cleared, the destroyer was a wreck. Fires raging, metal twisted, the deck littered with shrapnel. But she was still afloat. Later, when a fleet tug arrived to tow her back, a sailor from another ship whispered, "She's the ship that wouldn't die." Naval analysts credited the VT fuses for saving her. Without them, at least twice as many planes would have hit. In that single engagement, the weapon had shown its ultimate power. Not invincibility, but survivability. Elsewhere, across the battlefront, similar scenes unfolded. The battleship USS Missouri, later to host Japan's surrender, was nearly struck by a kamikaze on April 11. Gunners armed with proximity, fused shells, detonated 2 aircraft mid-dive, but 1-0, trailing smoke, managed to crash into the ship's hull. The explosion tore through her side, yet the battleship endured. The crew later recovered the Japanese pilot's body from the wreckage. They gave him a full military burial at sea, an act of respect amid savagery. Further east, the destroyer USS England, famed for her record of sinking submarines, was attacked by multiple kamikazes. Her VT fused guns shot down 4 planes in less than 10 minutes. A single hit destroyed 1 mount, but her defenses held. By May, the numbers told a clear story. The proximity fuse had transformed the nature of anti-air warfare. Out of over 1,900 kamikazes launched during the Okinawa campaign, more than 70% were destroyed before impact. The highest interception rate of the entire war. American fleet losses were still heavy. 36 ships sunk, 368 damaged, nearly 5,000 sailors killed. But, without the new fuses, those figures would have tripled. The technology's precision had altered not just tactics but psychology. Gunners now trusted their shells. Commanders no longer doubted the invisible science that had once seemed like magic. For the Japanese, however, every failed attack deepened despair. Pilots returning from unsuccessful sorties spoke of sudden explosions with no visible cause. Mechanics inspected aircraft riddled with shrapnel long before they reached the fleet. Some believed the Americans had built a sky minefield. Others suspected divine intervention. No one realized that the answer lay not in heaven, but in radio waves. As April turned to May, Japan's airfields emptied. Its last trained pilots were gone, its fuel reserves nearly dry. Yet the suicide missions continued, carried out by boys barely able to fly. The empire was bleeding itself dry. The invisible hand of American science had met the last cry of a dying nation. The Battle of Okinawa would grind on for 2 more months. 2 months of horror, both at sea and on land. But in the skies above, the outcome was already decided. The proximity fuse had rendered the kamikaze obsolete before Japan even realized it. By the time the final suicide waves faded, the Pacific was quiet again, littered with wrecks, marked by smoke, but ruled by those who had mastered the unseen. The war's deadliest battle had proven one truth: courage alone could no longer overcome technology. And as the last fires of Okinawa burned into the night, that truth would carry forward into the final days of the war and beyond. By late June 1945, the Battle of Okinawa was over. The island lay in ruins, its hills cratered, its cities burned to ash. On land, more than 100 Zalos and Japanese soldiers and civilians were dead. At sea, the U.S. Fifth Fleet was battered but victorious, its flagship still floating amid the wreckage of hundreds of destroyed aircraft. The kamikaze campaign, once hailed in Tokyo as the divine weapon that would reverse Japan's fate, had instead consumed the empire's last strength. Between October 1944 and August 1945, Japan launched more than 800 suicide sorties. Of those, fewer than 15% reached their targets. The rest were obliterated by radar-directed guns and the silent perfection of the proximity fuse. In the weeks after Okinawa, Japanese commanders faced a grim reality. Airfields, once bustling with volunteer pilots, were now empty. Fuel shortages left many planes grounded before they could take off. The Special Attack Corps, that had once symbolized national resolve, became a haunting reminder of what was lost: not just aircraft and manpower, but the illusion of divine protection. American intelligence officers, sifting through captured documents, realized the scale of Japan's desperation. Many of the kamikaze units had been assembled hastily from student pilots, mechanics, even teenagers drafted from school. Some had been told that success would save their families from starvation. Others were assured that their names would be remembered forever. Few believed it anymore. The proximity fuse, though born in secrecy, had made this despair final. Its introduction shattered the one remaining advantage Japan thought it possessed: the ability to trade one life for one ship. That trade was no longer possible. Reports from fleet commanders told the story clearly. During the Okinawa campaign, ships equipped with VT ammunition had an average kill probability 7 times higher than those firing time fused shells. Admiral Spruance's after-action summaries described it plainly. The new fuse has changed the balance between man and machine. But the price of victory was immense. Over 12,000 Americans died taking Okinawa, and nearly 5,000 sailors were lost to kamikaze attacks. The proximity fuse could destroy planes, but it could not shield the men below from the flames that followed each impact. On destroyers like Laffey, Bush, and Cassin, survivors lived with scars that never faded. The sound of aircraft engines haunted them for years. Some described waking in the night to the imagined scream of a diving Zero. Others remembered the smell of burning fuel, the smell that meant another pilot had died trying to kill them. The U.S. Navy began preparing for Operation Downfall, the planned invasion of the Japanese home islands. Analysts feared that Japan would unleash thousands more suicide planes, perhaps even piloted gliders and explosive boats. Yet deep in the Pentagon's archives, projections told another story. With the proximity fuse now universal, the U.S. hopping expected to destroy more than 90% of attacking aircraft before impact. Japan's leaders never learned the full extent of this technology before the war ended. By the time the atomic bombs fell on Hiroshima and Nagasaki in August 1945, the empire was already broken, its skies empty, its young men gone. The divine wind had failed. In the ruins of the airfields at Chiran and Kanoya, letters from dead pilots still sat in wooden boxes, written to mothers, fiancées, and younger brothers. Some were never delivered. Others were found years later, their ink faded, but their words unforgotten. I will become the shield of Japan. I fly gladly for the Emperor. Please do not cry for me. Yet in the skies above Okinawa, it was not courage that had decided the war. It was calculation, electricity, and the invisible pulse of radio waves. A new kind of divinity, forged not in faith but in physics. The Empire of Japan had offered its youth to the wind. The United States had offered its scientists to the storm. Only one of them would prevail. When Japan finally surrendered on August 15, 1945, its warlords and air commanders stood amid a silence that no radio could break. Cities were gone. Fleets lay rusting in shallow harbors. The last kamikaze units had been ordered to stand down only days before the Emperor's voice reached the nation. A voice few had ever heard before. In the ruins of air bases like Chiren, mechanics disassembled what planes remained. The hangars still carried the scent of fuel and sweat. Chalk markings on the concrete listed the names of pilots who had flown and never returned. Beside them, untouched aircraft waited for fuel that would never come. Across the Pacific, American engineers gathered their equipment from hidden bunkers and laboratories. The scientists of Johns Hopkins Applied Physics Laboratory, the men who had birthed the proximity fuse in secrecy, were finally permitted to speak. They had produced nearly 22 million VT fuses in less than 2 years. A manufacturing miracle, guarded under layers of classification thicker than any armor plate. At a press conference months later, one of them remarked quietly, "It was the fuse that made our guns intelligent." He was right. The proximity fuse had turned the ordinary anti-aircraft shell into a sentient hunter. It was the unseen ally above every ship, measuring distance at the speed of light, detonating at precisely the moment of maximum lethality. Its invention had cost the U.S. over $1 billion, but it saved untold lives. Historians would later call it one of the 3 technologies that secured Allied victory. Alongside radar and the atomic bomb, its impact was not limited to the sea. In Europe, proximity fuses equipped with modified safety systems had been introduced during the Battle of the Bulge in December 1944. There, they detonated artillery shells in the air over German infantry, showering them with deadly fragments. The effect was immediate and devastating. German survivors described it as the sky exploding. It broke the momentum of Hitler's last offensive. But nowhere did the fuse prove more decisive, or more haunting, than in the Pacific skies. For Japan, the revelation came too late. Post-war analysis by surviving officers, conserving officers confirmed they never understood the nature of the new weapon. Intercepted intelligence had mentioned radio shells, but engineers dismissed them as impossible. In 1945, Japan lacked the industrial base to reproduce such precision electronics, even if they had known the design. In the months following the surrender, American occupation teams documented the aftermath of the kamikaze program. They found rows of unfinished planes, photographs of pilots taken hours before their missions, and training manuals with crude sketches of American ships. There were no notes on how to defeat proximity fuses. There never could have been. Among Japanese veterans, reflections were complex. Some former pilots who survived training, but never flew missions later, described feelings of emptiness. Not relief, but purposelessness. They had prepared to die for a cause already doomed. Others expressed quiet admiration for the American technology that had stopped them, saying, "We fought with our hearts. They fought with their minds." For the U.S. Navy, the lesson was clear. Science had become the new battlefield. The proximity fuse represented not just an invention, but a shift in warfare. From courage to computation, from sacrifice to circuitry. In post-war strategy papers, admirals wrote of invisible weapons as the future of combat. That future would soon arrive in guided missiles, radar locks, and electronic warfare systems, all born from the same lineage as the fuse. The sky, once a domain of raw courage, was becoming a theater of precision. Yet amid the triumph, some engineers felt unease. Physicist Merle Tuve, one of the fuse's key architects, refused to celebrate publicly. He later said, "Every success we had was built on someone else's destruction." His words echoed the paradox of all modern war. Victory measured in loss. By the time Japan rebuilt, its pilots were gone, its swords melted, its skies peaceful once more. The proximity fuse, now obsolete in form but eternal in influence, became a quiet relic of a war that had forced humanity to choose between faith and physics. In that choice lay the end of the kamikaze, and the birth of a new era where machines, not men, would decide the sky. In the final years of the Second World War, two worlds collided in the same sky. One was ancient, built on honor, spirit, and the belief that death could still be victory. The other was modern, shaped by logic, electricity, and the invisible reach of science. When those worlds met above Okinawa, the result was not balance, but erasure. The kamikaze pilots of Japan carried with them a faith older than flight itself. That courage could overcome odds, that sacrifice could bend the course of destiny. They flew knowing they would not return, convinced that the purity of intent could triumph over overwhelming force. But the proximity fuse offered no emotion, no mercy, no hesitation. It simply measured, calculated, and ended lives with perfect precision. It was not cruel. It was exact. And in its exactness lay a new kind of power. The ability to decide war through data rather than valor. This was the quiet revolution of the 20th century. For centuries, warfare had been a contest of men, their endurance, their faith, their willingness to die. But in 1945, above a blood-red sea, it became something else. Machines began to sense. Weapons began to think. The kamikaze died believing they struck for their nation's soul. The Americans who built the Fuse believed they struck for survival. Both were right in their own time, and both were consumed by the same truth. Once technology learns to kill more efficiently than men can die bravely, the meaning of courage changes forever. When the war ended, the proximity fuse faded quietly into museums and archives. Yet its legacy remains in every radar, guided missile, every smart bomb, every system that destroys before being seen. It was the beginning of distance, the widening space between human intent and mechanical action. And so, in the silent sky above Okinawa, where courage met computation, the world crossed a threshold it could never return from. The age of sacrifice had ended. The age of precision had begun.